Welcome, folks, to the intriguing world of quantum mechanics, a branch of physics that seeks to explain the inexplicable, the bizarre, the truly extraordinary. You see, quantum mechanics is like that eccentric genius in the corner of the room, speaking a language that is both fascinating and bewildering. It's the rule book for particles smaller than atoms, those tiny specks of matter and light that you can't see but are everywhere around you, within you. Now let's imagine you're at a party. You see people mingling, some standing alone, others in clusters. In the quantum realm, this party would be a little different. Particles would be both mingling and standing alone at the same time. This is known as quantum superposition. Yes, it's a little mind-bending, isn't it? Then there's the peculiar case of light and matter. Picture a celebrity who is both a successful actor and a renowned singer, embodying two distinct roles. Similarly, in the quantum world, light and matter can act as both particles and waves. We call this the dual nature of light and matter. But the strangeness doesn't stop there. Imagine two dancers on a stage, perfectly in sync, mirroring each other's every move. Even when they are at opposite ends of the stage, they still move in harmony. This, my friends, is quantum entanglement. Particles, no matter how far apart, can be intertwined, affecting each other instantaneously. So why should we care about all these quantum oddities? Well, these aren't just theoretical musings. They're at the heart of technologies we use every day, from your smartphone to the GPS, guiding you home. Understanding quantum mechanics is like peeking behind the curtain of reality. It's a journey into the unknown, a voyage into the heart of the universe. It challenges our perceptions, forces us to question, to wonder, and to marvel at the beauty and complexity of our world. So buckle up as we delve into the fascinating and often counterintuitive world of quantum mechanics. Did you know that light and matter, like us, can have a dual nature? Welcome to the world of quantum mechanics, where the seemingly impossible becomes possible. Today, we're diving into the intriguing concept of wave-particle duality. This idea proposes that light and matter exhibit properties of both particles and waves. Imagine a football. It's a solid object, right? You can touch it, kick it, and see it bounce off walls. Now, envision that same football as a wave in the ocean, ebbing and flowing with the tide. Sounds strange, doesn't it? But that's the magic of quantum mechanics. Light, for instance, sometimes behaves like a particle. Think of photons bouncing off a mirror. But at other times, it behaves like a wave, spreading out and interfering with itself. The same goes for matter. Even something as small as an electron can exhibit this dual nature. It might sound like a wild idea, but it's been proven through experiments. One such experiment that beautifully demonstrates this duality is the double-slit experiment. Picture this: you're throwing a bunch of footballs towards a wall with two slits. Naturally, you'd expect to see two clusters of marks on the wall behind, corresponding to the two slits, right? But in the quantum world, things get a bit more complicated. When you fire electrons, tiny particles of matter, at a barrier with two slits, you don't just get two clusters. Instead, you get an interference pattern, much like waves in the ocean would create. The double-slit experiment shows that these tiny particles can act like waves, passing through both slits simultaneously and interfering with themselves. This experiment has been a cornerstone in understanding the wave-particle duality of light and matter. Isn't it fascinating to think that things aren't always as they seem in the quantum world? Imagine a cat that is both dead and alive at the same time. Sounds impossible, right? But in the realm of quantum mechanics, such a paradox isn't just possible. It's at the heart of one of the most mind-bending thought experiments ever conceived: Schrödinger's cat. Let's dive into the world of Erwin Schrödinger, an Austrian physicist who proposed a thought experiment in 1935. Schrödinger asked us to envision a cat inside a sealed box. Also in this box is a radioactive atom that could decay, triggering a mechanism to release a deadly poison. But here's the catch. There's a 50-50 chance the atom decays, and the same chance it doesn't. So until we open the box, we don't know whether the cat is dead or alive. Schrödinger's point wasn't about feline mortality, but about quantum superposition. You see, according to quantum mechanics, that radioactive atom is in a superposition of states, both decayed and not decayed, until we observe it. And since the cat's fate is tied to the atom, it too is in a superposition of states, both dead and alive, until we open the box. To simplify, think of it like flipping a coin. While it's in the air, the coin is both heads and tails. It only becomes one or the other when it lands, when we observe the result. That's superposition. This may sound utterly bizarre, and that was Schrödinger's point. He wanted to show the paradoxes that could arise from quantum mechanics, challenging us to refine our understanding. But he also gave us a powerful metaphor for the strange beauty of the quantum world, where things aren't as clear-cut as in our everyday lives. So, in the quantum world, things can be in multiple states at once until we measure them. It's a realm where cats can be both dead and alive, where coins are both heads and tails, and where reality itself is a kaleidoscope of possibilities waiting to be observed. What if I told you that two particles can be connected in such a way that the state of one can instantly affect the state of the other, no matter how far apart they are? Imagine, if you will, two dancers on a stage. They move in perfect harmony, every step, every twirl, every leap perfectly synchronized. Now picture those dancers miles apart, yet still moving in unison, mirroring each other's movements flawlessly. This is the magic and mystery of quantum entanglement. In the quantum world, particles can become entangled, their properties linked in such a way that the state of one instantly influences the state of the other. This happens regardless of the distance between them, whether they are a few inches apart or on opposite ends of the universe. It's as if the universe has its own strange and inexplicable choreography, a dance that defies our everyday understanding of space and time. Yet this isn't a dance of the physical bodies, it's a dance of information. When one entangled particle changes its state, the other instantly knows about it and adjusts its own state accordingly. It's as if these particles are speaking a secret language, whispering across the vast expanses of space and time, sharing their secrets instantaneously. Despite being a core aspect of quantum mechanics, entanglement remains one of the most intriguing and baffling phenomena in the universe. It's a concept that has puzzled and fascinated scientists for decades, challenging our most fundamental understanding of reality. It's an idea that seems to belong more in the realm of science fiction than in the rigorous world of physics. Yet it's real. It's a testament to the inherent interconnectedness of the universe, a reminder that everything in the cosmos is intimately linked in ways we are only beginning to understand. It's a notion that stretches our imagination, pushing the boundaries of what we think is possible. Quantum entanglement truly shows us how deeply connected the universe is. Now, you may be wondering, what does all this have to do with me? Well, let's bring it all back home. The strange and fascinating principles of quantum mechanics are not just theoretical puzzles. They have concrete implications for our everyday lives. Quantum phenomena form the backbone of numerous technologies we take for granted. For instance, take lasers. Their operation relies on the quantum mechanical behavior of electrons. Or consider semiconductors, the heart of your computer and smartphone. Their function hinges on quantum properties of materials. Even medical technologies like MRI scanners owe their existence to the principles of quantum mechanics. But beyond these practical applications, the quantum world challenges us to rethink our understanding of the universe.